Hey, let me show you the flow to do partial reconfiguration with Xilinx 18.3 tools. Um, so let me start from the very beginning. Let me close this. Let me get to the folder where I want to get started. So I just uploaded this project on GitHub. So if you can see in GitHub, it's called partial reconfig example. So the project is called GPIO PR because it's partially reconfiguring the GPIO block on my ZC104 board. What it does is um, it configured the XCGPIO block, so the LED pattern on the ZC104 will be changing when you download a new partial bitstream. So there are three patterns that I want to show. So the first one is all LEDs are off. So they are showing the pattern 0000. So that's a LED 0 pattern. The second one is two LEDs are on. So it will show pattern 0101. So it's called LED 5 pattern. So if I go to here, you can actually see the name LED 5, right? And then the last one will be 1010 pattern. So it's an LED A pattern. Um, so if I go to this project, I have a makefile there to do all the things. So I'm always doing this partial reconfiguration in a project mode. So you can also do non-project mode, but I prefer the packaged version of the design. So I always prefer the project mode. I always want to use the Tico flow without inferring any GUI because it's going to be faster. So let's take a quick look at the makefile. So it just, the general flow is it first builds the static design, um, create the block design without implementing it. And then the dynamic design, I create, configure those partial regions. Then I call the bitstream, build the bitstream target, which builds all the um, full bitstreams and partial bitstreams. Finally, I'm doing the time checking. This is only checking the static design right now, but this one still need to be improved so I can check timing for all the dynamic design as well to make sure there are no timing violations, right? So I'm building this step by step. So the first one is I want to build a static design. So I just run make static. So what I did is inside this project, I do make clean first. I don't want to do it right now because I have a background process running. Um, I can do after make clean, I can do make static, which builds a static design. So if I'm doing it here, so if you can see, so this is the result after running the make static. And then I can go inside this project and open it to see the block design. So let me see block design. So the Vivado 18.3 is installed on my server, and I SSH'd onto the server to use the Vivado. But you can see this is the 18.3 version. So I open the block design. As you can see, this is a relatively simple design. I have a few blocks there. So think PS in the middle. Have four clock reset block. Reset 0, 1, 2, 3 because I'm using four clocks, right? And then those actually interrupt the controller is uh, is some redundant. I don't need them right now, but I just left it there. let's just cancel this first. I don't want to run implementation right now. So those, some of those blocks are left from the base overlay. So I started this design from the pink base overlay on ZC104. I started trimming down the design so that I only have the modules that I want. So the most important part in this design is this GPIO0 hierarchical block. So it's a hierarchical block. And if you expand it, you see all XGPIO modules there. So they're controlling the LEDs, 4 LEDs, 4 push buttons, and 4 switches on CC104, right? So why am I putting all the IPs inside a hierarchical block? Because Vivado doesn't allow you to directly set an IP as partial definition, right? So the partial definition has to be hierarchical block. So I must group all 3 of them into a block. Well, actually, I'm only configuring this one. So as a matter of fact, I can only have this one um, inside a partition definition or a reconfigurable region. Anyway, I'm including all 3 of them. And during runtime, I'm going to configure the default value of this GPIO block. So you can see here, I'm using GPIO, the first channel, and the default output value is 0. And for different reconfiguration, I have different value here. So for example, I can put a 5 here as a default value or A. That's what I'm going to do inside, during this partial reconfiguration flow. So let's cancel that. So this GPL0 now is defined as a partial definition. There are multiple terminologies here. So there's partial partition definition, which is like like a region that you define for a partial reconfiguration. In my case, I define GPL0, the entire hierarchical block as the partition definition. And the second terminology is reconfiguration module. So in short, RM. So for each RM, you will generate a partial bitstream. So I have 3 patterns to show. So I have 3 reconfiguration modules, 3 RMs. And the third terminology is the uh, configuration, right? Just configuration. So one configuration is a combination of RMs, a specific RMs. So in my case, I only have one partition definition, but what you could have is you can have multiple partition definitions. For example, have another block right in front of the GPIO_0. Let's see it, let's call it extra block, right? So in extra block, you have 2 RMs. So in total, you can have, RM0 and RM1 in extra block. RM0 with the LED pattern 0 inside GPIO_0 can be one configuration. RM0 with LED pattern 5 can be another configuration. So you can see there are multiple combinations of RMs in different partition definitions. So in the example I just mentioned, since if you have 2 RMs in the actual block, you have 3 LED patterns or 3 RMs inside GPIO_0 partition definitions. Then in total, you can have at most 6 RMs, right? Sorry, not 6 RMs, 6 configurations. So that's the definition. So one thing that I need to, the main reason why I need to open the design and run synthesize, I just run the synthesize. As you can see, synthesis has been completed. The reason is I want to tell you guys how to define the P block. You need to define a P block that's a constraint. There will be a constraint file for your partial region. So all the partial configuration will happen inside that P block. All the static part outside of the P block will not be touched during during a partial bitstream download. So let's see. So you only have to do this once if you are successful. Um, since I'm doing all the stuff in a make flow, I don't have to, define the P block every time. I just have to kind of write the constraint file into an XDC file, and then I just keep using the same XDC file every time. Let's open the synthesized design. Okay, what you want to do, you have like an overview of the blocks here. It has multiple regions. So after you run the synthesize, you will have multiple stuff here. GPL0 is the as you can well, if you remember in the block design, the project is called GPL underscore PR, and the hierarchical block is called GPL underscore 0. So that's this thing, right? So I can right click it, select floor planning, select draw P block, and then I can draw a P block here anywhere on the board, and then we'll specify the resources. So if I click OK, you will see the utilization here to see whether, since I don't use a lot of resources for that, only use like 4% of the block here. This PR region is only using around 4% of the P block. Remember that you don't want to use like 90% of the P block because during partial reconfiguration, maybe some RM is bigger than the other. So you don't want to um, you know have a too tight resource constraint. And then when you do this, right, so by default, some the tutorial mentioned that you have to choose snapping mode or anything to go to, but I think it's by default it's already it already being on, I think. Anyway, we just choose on. Yeah, choose on, and then you have if you check the Tickle console here, you have a bunch of scripts that has been run. So what you can do is you copy those ones into an XDC file. So if you check my, I save it, I just did this for my project. So I have something like this, right? Create P block. So that's just the same thing copied from the Tickle console there. Right? You have to, include this constraint file in your project, right? I'm not going to save this because the only reason why I'm showing this is to let you know how to um, save or how to have the constraint file, the P block. So I don't want to save. I just want to exit, right? So that's the static design. So I want to clean this entire thing and start from the very beginning. So I just run make clean, and you can see those different Tickle files. I just run make simply to show the flow. So if you build the static design first, and then just the block design, and then do the dynamic part, then um, implement the bitstream, and then check the timing, right? So if you remember, there's nothing much about this different parts of this Tickle file. So if you check the first static one, is building the block design. This is nothing more than just a normal Tickle file. You can just, as long as you have block design, you can always use the Tickle command, write bd Tickle to have this one ready for you. Remember that you may need to include some IP repo in case you have some self-defined IPs or HLS IPs. They will be checked inside this Tickle file. And then the second one to build the dynamic part. So I'm setting different RMs, LD0, LD5, and LDA. Partition definition is called PD GPL0. PR region is the GPL underscore 0, which is the hierarchical block name, right? Overlay name and the block design name is both GPL underscore PR. And it's, well, you can just have a look at this one. I don't want to introduce this step by step, but it's a well explained Tickle file. Finally, I'm checking. Well, actually, I'm missing the bitstream building step. So I go to build bitstream. Yeah, it's it's launching synthesize first, and then build the implementation for the static design, and then for each child implementation, you will generate a partial bitstream. I will show you later the project structure, so you can see where to get those partial bitstreams and full bitstreams. Check timing is trivial, so I won't show you there, but let's wait until we get the project built successfully. Hi, the implementation just finished. So I can see that the project has been built successfully. So I go to project, I see about the project folder. If I go inside, let's have a look at um, the structure of the project. So if you go to sources, you have multiple block designs. So those RMs are just the block design of um, the partial region. So if you check the Tickle file, you will see it's not the whole block design, it's just the RM0. I'm sorry, the partial definition, the partition definition region. Yeah, it's not a long one, it's only like 300 lines. Same for the other RM LED 5 and LED-A. LED0 is the same, I think. It's LED0 might be the default RM, which is the same as RM LED0. So GPL PR is the whole block design. So inside this path, you can actually see the entire block design. So if you open this, you see this is a long list, like 1800 lines. Let me open the block design. I don't know if I mentioned this or not. Oops. Maybe I forgot to mention something that I want to show you guys the thing. So, well, some people may want to get the Tickle file to generate to be shipped along with the bitstream for the overlay structure. So that's the place where you can get the system tickle file. It's actually the same as this one. It should be the same, or maybe just some very simple difference. And what's this? I think this is a partial one. Yeah, so ID 0, ID 5 are those partial ones. Yeah, you see only 300 lines. So this is the GPIO underscore PR is the whole block design. LED 0, LED 5, and LED A are the partial designs. So you may wonder how I got those tickle file. It's easy. So if you have your let's open the block design. Let me show you how to generate those partial tickle file. And I'm using the partial tickle file in my flow to generate the corresponding block. So if you go to this GPIO 0, after you set it to be RM, you see there's a PR on the block. So if you expand this, you can select different RMs. But I think if you double click it, I cannot double click because it's already been put into PR. So originally, if you expand this, oh, I can still open it. Yeah, I can generate block design, right? And then after I generate block design, you will actually see the place I just showed you into GPIO PR sources, PD, and you will see hardware handoff. You will see this .tickle file. I think the one I got is just a rename of this of the RM0 handoff file, right? So if you double click it, what have you changed from one RM to the other? So if you look at this IP GPL LEDs, inside IP configuration, I can change the default output value. Not sure if I mentioned this. So what I did was I changed it to 5 and change it to A for different RMs. So there are 3 values. Yeah, maybe I don't mention it. I don't know, but there's nothing that we want to check there. Now, if you look at this structure, go to the Vivado file. I want to get the bitstream out, right? How do I get bitstream? Go to GPL PR, runs. You have different implementation. Implementation 1 is the full bitstream design. So if you go to this folder, you will see a bit file somewhere in there. Let's see, where is the bit file? Here. Second, copy this one and go to here and copy it here. No, that's a partial bit. Sorry. GPIO, maybe let's see, runs. Because the partial bitstream always have the partial let me see. Yeah, it's a partial. Here. Sorry, it's right there. So this design implementation 1, because implementation 1 is based on the default RM, which is LED 0. So that's the reason why you see a GPIO LED 0 partial bit there. But I won't be using this one. I just use the full bitstream because it contains this partial bitstream as part of the content. So the GPIO PR wrapper bit. Go to here, I copy it here. It's 18 megabyte. You see, it's not a small one. Just rename it as GPIO PR to avoid confusion. Go to runs. You have 3 child implementations. So child 1, partial bit here. Copy it here. The other implementation 1. LED5 partial.bit. The final one. All these steps can be scripted. So hopefully, in my makefile, I don't have to do this manually again. Just copy it from various places. So you have all the bit file, the full bit stream and 3 partial one. As you can see, the partial ones only 400 kilobytes. The full bit stream is 18 megabytes. You see that's the difference, right? You know that's the partial bit stream. Okay, let's get to the Jupyter notebook. So then what I did was I copied those files onto the board. See if I have the Samba access to my board here. Jupyter notebook, I have partial reconfig example. I just copy those bit files. Please ignore the bin file for now. Maybe I can show you how to generate those bin files. I delete those bin files. So, those 4 files are the files copied from the Vivado project. And let's go to the IPython notebook. I'm going to clear this. Let me show you the results. I will run this one by one. At the same time, I will show a camera output there. So let's see. Please ignore the warnings there, as this image is not final. I'm just doing experiment with it. In the final release of ImageV 2.4, I will get rid of those things. So I'm using the PYNQ bitstream class, using the full bitstream as the basic bitstream. Just calling some functions to be able to convert the full bitstream to a bin file. So after I run this cell, I should get this GPIO_PR there. You see there's new file, right? Because the FPGA manager only accepts bin files. Okay, and then I do the same thing for the 3 partial bitstream as well. I convert them to bin file. To double check, you see the bin files have been created. This notebook is shown on GitHub, so you will be able to call the same function. And now I'm downloading the full bitstream. And I'm recording a video at the same time on my machine. So you can see the LED lights, just there are 4 of them right next to the push button on my ZCU104. But you can see all of them are off because I'm using the full bitstream, which use LED 0 as a partial bitstream. So it's showing the LED pattern 0. Now I'm going to run the LED 5. So as you can see, it's 0, 1, 0, 1. So from top left to right bottom, right? So 0, 1, 0, 1. Okay, I'm going to run, sorry, I cannot do this in a stable way. I have to make sure that I'm running the code. Also, I'm holding the camera. Okay. Now I'm running the next one. After it completes, you can see its pattern has been changed to, oh, sorry, where my fingers here, 1010. So that completes the story. So able to run the partial reconfiguration on ZCU104. Yeah, if you have any questions, you can leave comment, or I can check that for you. Bye.
You can see the four LEDs right next to the push buttons are all off because I'm using the Fuji screen. Now I'm running LED 5 perfectly. Okay, now you see from the top left to right bottom, the pattern is 0101, right? Now I'm going to switch to the positive pin 1010. You see it shows the correct pattern.